Hello, my DevNation friends. I hope you are doing well. It's a pleasure to be here for a new Tech Talk. So, I'm your host today. 2 weeks ago, it was Natalie, I think. This week, it's me. So, I'm Sebastian Blanc. Maybe you know me from the DevNation, the show, or from the deep dive. And today, we have a really exciting topic with an awesome speaker. So, without waiting anymore, let me bring to the stage Danielle. Hey, Danielle, how are you?
Hi, Sebi. It's good to have. Thanks for having me. It's really good to see you again after Devon Nexus.
Yeah,
Yeah, I'm
exactly.
I'm pretty. I'm doing pretty good.
Okay, and where are you based again? I
Yeah,
forgot.
sure. So I'm based in Boston, in the
And
East
Boston.
Coast. Yeah. So
Okay,
today is a little bit chill.
okay.
Yeah. Than last week. So last week, so almost 75, almost 80. It's a pretty much a summer weather, but today is a
Yeah.
55.
Okay.
Little bit chill, like just New
Yeah.
England weather.
Yeah. Yeah. Well, I'm live from south of France, and I can tell you here it's summer already since 2 weeks. It's really hot. I have my small airco here. I turn it off because it makes a lot of sound, so it's getting really warm here. And you are going to present us a really exciting topic: um, event-driven autoscaling using KEDA and Knative integration. So I'm really excited about it. Daniel, the stage is yours. I give you the screen share. I remove myself and see you at the end for the questions. Good luck.
Yeah, that'd be great. Thanks for the great introduction. And hello, everybody, and good morning, good afternoon. It depends on where you are. So today I'm going to talk a little bit about event-driven auto-scaling using KEDA and the Knative integration. Maybe some people already heard about what KEDA is, Kubernetes Event-driven Autoscaling. And the Knative is allows you have serverless function capability. So let's get started right now. So just who am I? Just a little bit real quick. So my name is Daniel O. I'm working for Red Hat as a technical marketing major slash developer advocate, specialized in cloud native runtime, for example, Quarkus, Spring Boot, and Node.js. And I spend a lot of time to put cloud native runtime application into serverless and service mesh with Kubernetes and slash OpenShift. I'm also responsible CNCF ambassador. Try to help a lot of people how to build a cloud native application and architecture and whatever the DevOps platform with the GitOps practice and then serverless and service mesh practice, etc. Here's a few contact information. If you want to reach out to me, my Twitter and then my Bitly URL, Daniel TV YouTube channel, and my Twitter. Just feel free to reach out to me if you have any question around this technology, but also CNCF projects. Okay, so let's try to take one step back, understand what auto scaling architecture looks like in Kubernetes. For example, you can have multiple microservice application as a running on pod on Kubernetes. For example, inventory application and catalog application. Just imagine that your retail app, business application like online shopping or something like that, and the order card payment. Each microservice application deployed on Kubernetes as a pod with the deployment manifester on Kubernetes. And then if you want to scale that application automatically, you just define horizontal pod autoscaler, aka HPA. And each HPA resources decide when your application pod will be scaled out and in based on the resources, the CPU memory. But this is a really good architecture for auto scaling on the Kubernetes. But what if you could have external services which impact your uh, existing running application on Kubernetes? So for example, you have a Prometheus put together the metric data or a Kafka source to process event-driven messaging from external system, or the Azure monitor or the AWS as the monitoring or the event-driven system. So this is a bunch of stuff is a common practice and use cases that you could integrate the external services with the inside the Kubernetes application. In that case, some of the autoscaling should be what must be designed based on event-driven messaging or event-driven metrics rather than CPU memory, because it takes some time to measure the metrics based on CPU and memory. So, but in order to uh, redesign and handle the external services with your existing Microsoft application, you could have the custom metric, a custom autoscaling infrastructure layer on top of this box. You can see you can add Amazon CloudWatch metric adapter, or you can have Promise metric adapter or Azure Monitor metric adapter. You can have a multiple custom metric adapter, but the problem is here you can have enable only one metric at once. So some of the application, for example, inventory, needed to aggregate or communicate with the submetric data with the Amazon CloudWatch rather than Prometheus or Azure. But in that case, you can just auto-scaling the other application part, for example, order or card related to Prometheus metric adapter, which consume the event messaging from Kafka server. But you cannot auto-scale inventory because you cannot enable Amazon CloudWatch metric adapter at the same time. So this is just some potential problem if you wanted to auto-scale your application based on event-driven metric rather than just standard auto-scaling based on CPU memory resources. So this is the reason why KEDA was designed. So once again, the KEDA is the Kubernetes Event-driven Autoscaling. It's a principle, and then it invented by Red Hat and Microsoft a couple of years ago, and then he actually donated to CNCF project. It's now incubated project in the last October. The current version is 2.6, and then you can go to this keda.sh URL. You can find all detail. A little bit detail about this KEDA. So KEDA actually allows developer to scale standard Kubernetes manifesto, for example, deployment or job or existing custom resources. And there are more than almost 50 built-in scaler to handle external services. For example, Kafka, Prometheus, or RabbitMQ, and Amazon services, or Azure services like a Monitor, etc. And then all resources will be scaled based on events message rather than just a CPU. For example, you got a bunch of the messaging from Kafka topic. The application needs to consume that messaging from Kafka topic. So you have one criteria to scale your application based on that measuring messaging rather than the CPU memory utilization on the pod. But one good thing is KEDA does not manipulate the data itself. And then you can also install KEDA using operator or Helm chart. So with the KEDA, you can improve your auto-scaling infrastructure. For the example here, you could have a multiple scalar controller, and then the behind the scenes, the KEDA scale controller actually trigger existing horizontal pod autoscaler HPA, and then you don't need to HPA resources for each application pod. You can see here the middle of the side, you can define scaled object, and then each scaled object just calls scale controller, and scale controller call to your backend HPA to scale from maybe 10 or 100 pod based on event metrics. And also scale controller only handle from 0 to 1 and 1 to 0. And if you need to more scale more than one pod, the replication number, HPA will intervene and then scale your application. So now you can have multiple resources and multiple external services whenever you define scaled object. So inventory application, you can have a scaled object to get metrics data from AWS CloudWatch. And then catalog could be integrated with the Apache Kafka for auto scaling. And then cart application enable the metrics data based on auto scaling with the Azure Monitor. So here's a little bit detail how KEDA works here. So of course, KEDA absolutely based on Kubernetes, and then you can define scale object or scale jobs. Scale object just manage your standard objects, for example, deployment, and the job is a little more batchy, the jobs, something like that. And then the message workload from scale to 1 and 0 to 1. And then, so behind the scene, I already mentioned here, so HPA, you can use the KEDA autoscaler actually call to horizontal path autoscale to scale your application, like a 0 to 1 and 1 to 0. Okay, so here's a quick example. How to define scaled object. For example, here is the one important thing here. So the minimum replication count and the maximum replication count, and then what is a trigger? So for example here, so I want to auto scale my application based on the Kafka source. So that's why I set it as the example as a Kafka type, and then you can specify the Kafka server's detail. For example, bootstrap server URL, like a service name and the port name and the consumer group and the topic name. And this is all I need for Kafka source to auto scale my application based on the metric which comes from the Kafka server. So what about the serverless auto scaling? So why we need to talk about serverless in this moment? So a lot of people saying event-driven application really feasible in the serverless, because serverless application just scale up, scale and down, depends on the network traffic. And then which means all about event-driven application, just like a serverless. So if you want to scaling serverless application as a part of an event-driven application, how do we do that? So one of the interesting project, maybe you already know the Knative. So Knative is built on Kubernetes, and then Knative allows developer to manage and deploy your application as Knative service, which provide exactly the same capability, almost similar capability like a serverless, just like a Lambda. And then, but here are the two, some of the differentiated between KEDA and Knative. So for example, here, the KEDA only scale standard Kubernetes resources like a deployment or pod, something like that. But Knative, it deploy different resources like a Knative services. It's not standard services. It's not standard deployment. And then the KEDA just keep monitoring your application status and then just scale out. But the Knative, they have own autoscaler, not HPA. They own Knative scaler, and then that scaler trigger the application scaling like from 0 to 1 or 1 to 0. That's why we could say put and push model. And there are a few more things I'm gonna really explain in the next second demo here. So I'm going to showcase 4 different demos today, but my Kubernetes like OpenShift cluster just like some issue. So let me try to log in a minute. But if I cannot log in my OpenShift cluster, but don't worry about that. I actually create the related video. So maybe I can play the video and showcase how the demo works it. So the first use case. So we're gonna do try to auto scale the standard application based on HPA using CPU or memory utilization, but this is not event-driven auto scaling. The reason why I want to try to showcase is to really be helpful to understand what difference thing between event-driven auto scaling versus just the standard auto scaling, even if the application consume the event messaging from Kafka topic. Okay. So let's go into the demo. And here's my OpenShift cluster. Okay, here we go. Oh, thank God. So I already installed a bunch of the operator. As you can see, here is the Red Hat integration AMK stream, which allows me to deploy Kafka server. And then here is the KEDA. As I mentioned earlier, you can install KEDA as operator, just like I did it, or you can install KEDA using Hamchar. So I use operator, and this is OpenShift serverless based on Knative. So with that, you can deploy application as serverless. So I already installed 3 operator, and then go to developer console. I already create a Kafka topic in my project, the first project here. So Kafka-HPA. And then let me try to log in this OpenShift cluster from my local environment. Okay, luckily OpenShift provide the login token. And then, okay, here we go. I just log in my local host, and then here is my current project, Kafka HPA, which is good. Okay, so I already installed, to save my demo time, my Kafka topic here. The topic name is my topic. The cluster here, you can see the zookeeper, and then here's my Kafka topic with the 3 the high availability paths. Okay, so go to my terminal, and then I'm gonna open my application here. So here's my first. I'm gonna make it bigger. It'll be better for you, hopefully. So here's my Quarkus application. So Quarkus application, just in case you never ever heard about the Quarkus before, the Quarkus Kubernetes native Java framework is to really fit in the cloud-native application development, but also serverless application, because Quarkus provide a lot of developer experience feature, for example, live coding and the continued testing and dev services, which allows you spin up your container image automatically, for example, database and single sign-on, and then key lock, single sign-on in a database, and then the messaging broker, and a lot of the integration container automatically stand up. And also, the Quarkus provide 2 different build strategy. One for just in compile, like creating job file, you can running on job file on top of the JVM. And the other one is to provide the native compilation, which allows developer to packaging application and running without JVM, because this is based on ahead of time strategy, and they're running on substrate VM, actually grab VM, which is make a super fast response and startup time, as well as tiny memory footprint. So this is my sample application to consume the event messaging from Kafka topic. The topic name is my topic. It's pretty simple. If you have some experience to develop reactive application based on like a Spring Boot, there are some bunch of different methods and API you have to implement on Spring React, which is totally different architecture or development practice compared to Spring Boot application. But the Quarkus, one of the great and the beauty of the Quarkus you can develop imperative application as well as a reactive application at same method, and then you just need to write in a proper annotation which make your method and a class for imperative application or reactive application. So for example, you can see income annotation. It allows this method, a receiver method, just consume the event-driven messaging from my topic, the topic name from my Kafka. It's really simple. And the application pretty simple. I just print out the messaging from the record. And then here is my resources. And then there are a bunch of resources here. So first of all, I'm going to deploy this application to my OpenShift cluster. To do that, you can use a Maven command line, like a Maven or Gradle. But today I'm going to use a Quarkus CLI. Quarkus CLI is pretty simple for developer. You don't need to remember all Maven command line on parameters and arguments. The Quarkus CLI give you autocomplete functions, as well as they're pretty much easy and good developer experience for you. So I'm going to build the Quarkus application. I'm going to scale unit test for this time. And then it automatically packaging. Oh, yeah, I need to go to right directory. Okay, so now I'm going to Quarkus build. It will build my application like a job file first, and then go to containerize the application using Docker or Podman. And then lastly, it will push the containerized image into containerized. In this case, we're gonna push the image into integrate containerized inside OpenShift cluster. But you can also push that image into external containerized registry, for example, Docker Hub or KEDA.io or Google Container Registry, etc. So, and last step, the OpenShift try to pull the image and then just running on one of the available worker, just like a Kubernetes feature. So, and then you can see there are multiple steps how to containerize this application. When you go back to here, and then there are already generated Docker file, which is one of the good feature of the Quarkus framework. When you generate the Quarkus project, you Quarkus CLI or download from the code.quarkus.io, and this Docker file automatically generated to build your application as a container just in case for the JVM or native, etc. Okay, let's go back to here. I just build success, and then here we go. My application Quarkus is running, and then go to view logs. You can see, so my topic is enable. Here's a Quarkus Race version 292, and there are a bunch of extensions like a Kafka client, and then like a deploy to Kubernetes, and a reactive application to reactive messaging stuff. So now one thing I need to do is just you can see that I can manually scale and scale down. So in order to auto scaling, I need to set it up the auto scaling here, the Quarkus, and then like a minimum 1 and a maximum 10, and CPU utilization percent, like a 75%, which is a pretty normal use case. I just set it up and then go back to console. You can now see the arrow is gone, which means that this part will be auto scaled by Kubernetes and not me like a human. Okay, so back to the ID tool. I just created a few the job YAML file. This is the actually run the Kafka produce performance test bash script, which already exists inside the Kafka server. So I just use that, and then here's a bunch of the parallelism, and then it will run 5 jobs to keep generating the dummy message with a 10,000 record size, and then it's maybe a million messaging generated every single second. I just copy this YAML file and then go back to I open the console, I can just import YAML file and back to the topology view. And then the application, here is the job, will be create a file and click on one of the job file. You can see the record just generate and send to Kafka topic. And then back to the topology view, and then here the Quarkus and the view logs. And now you can see there are so many messaging just consuming from Kafka topic. And then this application and observe here and observe here, and you can metrics. Okay, or go to resources. Here we go, HPA. Now the target 75%, but the current metric, it takes some time to aggregate the utilization of a CPU. It takes some time, but in the meantime, your Quarkus application actually keep consuming and processing the messaging. Maybe sometimes it will end up with like a latency for the end user experience. So it takes some time to auto scale this application, and then just give it some moment, and then it will scale out. In the meantime, let's go back to slide deck and just really move on. The next use case is here. The second use case, we're going to redesign this auto scaling based on KEDA. As you can see, now we have a KEDA here, and a KEDA just pull the metric and from Kafka topic, and then in the end, the KEDA trigger the application auto scaling, specifically Kubernetes deployment. So this is based on event-driven. We're not going to scale based on CPU or memory utilization. So let's go to that demo as well. So here is the application still just one part, which means it takes some time to scale out based on CPU memory utilization. Let's switch another project, KEDA, Kafka KEDA. I also create the same Kafka topic here. And then when you go to the application, and here is the same application, but I'm gonna use this YAML file, the set it up, the Kafka topic, and then the same application. So because I want to say the KEDA only impact the standard Kubernetes resources, for example, deployment. So I just create a new deployment here, back to here, and then needed to create a new scale object, and the same name is the EDA. It's the deployment name, Quarkus EDA demo, just like here. And then you can actually change the this pod just to represent the Quarkus approach.io, and on time equal Quarkus. Okay, now you can see that. And then I'm going to create that auto scaling scale object, and then once I create it, automatically scale down to 0 because there's no network traffic at this moment. So that's why there's no event-driven messaging. So just scale down to 0, just like happening. And then I'm going to use the same load job YAML file based on the Kafka project performance testing here. And just create that. And then back to the topology. And it will start, and then pull deeper on the application start. And then click one, the messaging just starting, generate, and send it to Kafka topic. And then back to the topology view. And it will scale up soon. In the meantime, let's go back to our Kafka HPA project. As you can see, the job is done, and then our Quarkus is scale to 10. So, but it's already done all the load testing, but it still is scaled out to 10. When you go to logs file, and then it will still processing the application because it takes some time to scale out, and it also takes some time to scale in as well. So go to autoscaler HPA. Now as you can see, the current is only 2%, which means it's already done to scale out. And now it takes some time to scale in after some time period. Okay, so try to back to the Kafka KEDA. And now you can see it's already scaled out to 10. It's pretty much faster than just using HPA. So this is the actually event-driven autoscaling on Kubernetes plus KEDA. And now we go back to, and in the end, one more thing. In the end, when the job is done, and then the application will be scaled down to 0 based on KEDA. But when you go back to this namespace based on HPA, it will be scaled down to 1, not 0. That's one of the big different thing. And also how much time we needed to scale out instantly and scale down. That's another big different thing between only HPA and KEDA. Okay, move on to the next use case. Back to the slide where. So next case is a serverless. In the serverless, as I already mentioned here, is KEDA. So when you go to the right-hand side, this is a new designed architecture. So we have a Kafka topic here, and then here is we need to create the Kafka source, which is one of the integrated feature, Knative eventing with the Kafka. So when they create the Kafka source, so Kafka message just sync into Kafka source, and we send it to actual application, which is Knative services. And then the Knative autoscaler keep monitoring our Knative service, and then it will decide when these services will be scaled up and down. And then, so one of the good thing is you can handle cloud event messaging. So for example, you got a lot of different type of the messaging format. For example, I want to use a JSON format. I want to use the binary format. I want to use like a protobuf type format to manage my event-driven messaging. But you sometimes needed to put together the old application which needed to use different messaging format. It's a pretty complicated to handle all kinds of stuff at the same time. So Cloud Event was designed for handling and they provide a standard messaging format, regardless of your application runtime or your messaging server. So Cloud Event really good, specifically Cloud Native Distributed Environment to manage multiple types of event-driven architecture or tools. But the problem is you have to change your application code to consume cloud event messaging. So this is one of the caveats when you use Knative eventing to manage a cloud event. And then let's go get back to the demo and then how it works this kind of stuff. Okay, so I'm going to switch another project here. So, and you go to the one simple Java application. You can see just the cloud event, but it's just simple event stream, and then the same thing, just print out resources, and then go to application, and then here is the we're gonna deploy to Knative. But for that, in the previous project, you can see we're gonna deploy to OpenShift, but now there's a new property here. We're going to deploy to not this one. Here we go. So we're going to deploy Knative, which means that this application deployed to as Knative service with the Quarkus. This is a really pretty good feature for developer to deploy existing application to as Knative services. Okay. So there's a whole bunch of the application property here to deploy this application to OpenShift. So I'm going to switch it to another project like a KEDA Knative, a Kafka Knative. It's the same. I already installed the Kafka topic here. And then I needed to change my project to Knative, and then also change it to project here, and then I'm going to build and deploy this application. Here we go. And then it almost the same process. So we're going to build this application as a Java file. I'm not going to try to use a native compilation at this moment, but if you need a more high performance result to deploy application, specifically serverless, I suggest to use a native compilation, but it really takes some time longer because once we packaging application, we need to create an executable file natively and then packaging container. So it really takes some time. So in the reality practice, you might need to add the native compilation process as a part of your GitOps pipeline or DevOps pipeline, rather than every single time you do whenever you change the code on your local environment. And then once we deploy this application to OpenShift dash Kubernetes, you combine the little bit different icon on OpenShift Dev console, which represent this is the not normal application, but it's more like Knative service from Knative serverless application. Okay, I just deployed that and back to the here. So now we have a new application, a little bit different, and then you can see here is Knative services. And here the revision, maybe you can change it a little bit revision to showcase this is a Quarkus application, not a Node.js or not a Python. All right, so now with Quarkus and you go to view logs. And then now we can see the same. Here is just the same 292 version, and then running on JVM, same Maven dependency we have. Okay, so the one interesting part, we need to 3 seconds to start up. When you have a native compilation, it may be maybe 30 millisecond start or something like that. Okay, so back to topology view. Now I gotta go back to my ID tool, and then here is the one thing I have to do here. I need to add Kafka source, as I mentioned earlier, and then back to here. And in the meantime, your application automatically terminated, which is exactly the same behavior of serverless, like Amazon Lambda. The default time period scale down to 0 is 30 seconds. You can change that like a 1 minute or even 15 seconds. I never ever tried to invoke the application in the meantime. That's why this application terminating, and it will be scaled down to 0, just like here. And then I'm going to add the Kafka source, which consume the events messaging from Kafka topic, and it will link to Knative service here. So Quarkus EDA Knative demo, which is the same service name as my serverless here. And back to top view. Now you can see the Kafka source is the link to your application. And then I'm gonna back to the my ID tool. I'm gonna use the performance load script. And then I just click that. And then it automatically start up. But you already saw that the automatic startup because I just tested a couple minutes ago before I just started this DevNation talk, which means my Kafka topic actually still a bunch of the event-driven dummy messages. It's automatically just send it to Kafka source, and then Kafka source just send it back to my serverless function in Quarkus. That's why the application automatically start up when I add the Kafka source here. And then go back to here, and then click on the view logs, and you can find a bunch of the event messages keep consuming from Kafka topic. Okay. So the one interesting part here, you can see this is only one part. So whatever you send the messaging, how much message you want to send it to, but it already scales 0 to 1. And then it's sometimes overflowing your pod or show like a little bit latency to process, like some web rendering or so return your RESTful API, something like that. So let's go back to quick check to HPA. It just if it is scaled down, as you can see, now it's scaled down to just one pod here. And then go to Kafka with the KEDA. And now you can see there's no running pod. So two different things based on HPA and KEDA. And now we have go back to Kafka with the Knative. It's still one pod, and then still the job is running. It will generate 5 million event messaging every single second. It will send it to Kafka topic, and then it will consume through Kafka source into our Knative service application based on Quarkus. It takes some time to consume 5 million messages, and it will eventually scale down to 0. So now I'm gonna back to my slide deck and then go to the last use case, which really I want to showcase today. So what about event-driven serverless autoscaling? So previously, it's not technically event-driven because the even though it's consuming, but not like scaling the multiple serverless application. So here is the sandbox project integrate KEDA and Knative. Some people say, oh, Knative a little bit like a compatible thing with the KEDA because KEDA auto-scaling application, Knative auto-scaling application. But Knative a little bit more focused on serverless, and KEDA just focus on the normal application. But the auto-scaling perspective, the two projects provide the same capability. Even behind the scene, you use different autoscaler and different algorithm and mechanism. But what if we could integrate the KEDA and Knative and then provide a more great features? For example, KEDA can be used to autoscale Knative eventing infrastructure. Here is a Knative eventing source or a channel. And in the end, it will autoscale the infrastructure itself and then the application as well. And then we got to still working on this project by Red Hat and then Microsoft and then a lot of the vendors and individual contributor. And then one of the goal of the KEDA and Knative integration, the KEDA in the end scale Knative service itself, just like we auto-scaling normal deployment path. So here to finally redesign ultimate goal, auto-scaling event-driven application on top of the Kubernetes with the KEDA and Knative. A little bit complicated, maybe you feel, but just the point is you can have a two compound here, Knative, KEDA. So KEDA responsible for the scraps of event metric from Kafka and then just scale the Kafka source. This is eventing metric infrastructure, and then it based on that increasing the Kafka source is automatically scale your Knative service based on Knative autoscaler. So this is really good. So previously version we actually the Kafka source deploy as pod, but the latest version of Knative and then the Knative source not going to deploy as pod, is just integrate in the Kafka infrastructure. But in the future roadmap, it will be come back to deploy as a pod once again. So let's go back to our demo environment and then try to deploy KEDA and Knative at the same time. Okay, I'm going to switch my last namespace, Kafka-KEDA-Knative here, and we will show 3 Kafka infrastructure here, and then back to my IDE. And the one thing I need to change in my application here, so I'm going to change my image group, which is a namespace, Kafka, KEDA, Knative. And here's a bunch of my Knative configuration, which is actually related the KEDA stuff. So this is the actual how to scaling and how to the scale up and the target and the min-max, etc. And then back to my terminal, I'm going to change my project, Kafka, Knative. Oh, this KEDA first and Knative. Okay, now here we go. And then I'm going to just run Quarkus build unit test here. And then just remember that the previously, and back to the here, so previously into KEDA and Kafka project, we actually create the scaled object manually when you just open import YAML editor, and then we just paste the Kafka scale object manually, and then it will end up with increasing your application based on KEDA controller. But with the Quarkus annotation, I want to show that here it's automatically scaled up, set up the scaled object automatically when you deploy this application into Kafka KEDA native project. Back to here, and take a look back to our terminal window. So this is the same process, just packaging application, and then now we're gonna you can see multiple spec, which is based on Docker file to packaging application as a container, and then we're gonna push that image into integrated container registry here, and then just done, and then we just deploy the application as Knative services serverless. Okay, and now we have an application, and now we also create the Kafka source for the Knative. And then the one different thing is here, let's go back to here. And then I'm gonna make it bigger. And then the service name here. And then here is the KEDA autoscaling annotation. So this is make this Kafka source will be scaled based on KEDA. With that annotation, I just create that. Back to here, and now the application here, and then application automatically already starting, and then go to log4j and job file. In the meantime, it did. I once again I already testing just a couple of minutes ago, so that's why the application automatically scale. So try to once again to create the job. And then it's super fast auto scaling. Even this is just serverless, but when you go to here, it's 3 pods scale. And then we have a new job in the 5. And back to here, so keeping sending messaging to the Kafka topic. And then it automatically and it's really flexibly scale out and in based on event-driven messaging. So I'm going to a little bit change the label once again, showcase the Quarkus thing at one time. All right, and you can see the pod is now 4. So data go to here. So now you can see the pod is now 9. And this is a really bit super fast, but in the meantime, to scale down to 5 and scale up, scale out, and it's a little bit flexibly. That depends on how much event messaging comes from your Kafka topic. Not just scale out just once, really bit differently handling by HPA. So this is the how to redesign our auto scaling for event-driven application on the Kubernetes. All right. So I'm gonna do just summarize today's topic and then go back to my demo environment, how to it to scale down to 0, and I'm gonna more than happy to address any question. So here's the thing: Knative and KEDA sandbox to integration effort. You can also use Kafka source. We showed today. I will show that because Kafka, one of the popular common event-driven architecture, event-driven infrastructure, and then you can use the AWS SQS, and then Redis Stream and a RabbitMQ broker. And then just to there are so many related technical video and the topics. I already push it into my YouTube channel. Here's a Binny URL, Daniel TV. You can scan the QR code. Yeah, feel free watch it and keep learning. And also, don't hesitate add some comment or a suggestion on my YouTube channel, and feel free subscribe to it as well. It really helpful for me keep creating the valuable and technical tutorial and demos. So here's the 4 takeaways from today. So KEDA is Kubernetes Event-driven Autoscaling. It's super simple. And then KEDA just pull model and Knative pushing model. And then so KEDA only influence standard Kubernetes resources, but Knative only deploy Knative services. It's a unique resources rather than a deployment or a job. That's like that. And then KEDA autoscaling, Knative eventing infrastructure, which is integration with the Knative and based on event autoscaling KEDA annotation. Okay, so that's what I have today. Now we gotta go back to the demo, and then you can see the pod scale down to 5. And then one last thing, go back to Kafka Knative. Then it's still colony 1, which means it will eventually scale down to 0. Okay, so I'm gonna give some moment, ask some question, and then the question here.
Hey, thank you, Daniel. That was awesome. There was one question not directly related to what you showed, but was more a question about Quarkus regarding Spring Boot. So I gave some answers, and
Sure.
especially if you want to, if you're doing scale to 0, auto scaling to 0, and you want a really fast startup time when your first event comes in, then you really want a fast startup time. And that's another use case where you really want to use Quarkus in combination with Knative of KEDA. So that's
yeah, absolutely. So as long as you want to use the native compilation with this new architecture, for example, KEDA plus Knative with the native compilation with the Quarkus, it's much faster than a startup time when the new message comes first. Yeah, that's really a really good point. That's really what I wanted to showcase today. But it takes some time to have native compilation in the right demo.
And well, I have a question about KEDA, and it comes with a whole set of scalars that are already available, but you can also write your own custom specific trigger scalar. I don't know what the correct name is.
Yeah, you can actually make that, but so the one thing is, as I mentioned earlier, you can create the custom scalar metric for the KEDA itself, but you cannot use that custom thing for Knative and KEDA integration.
Okay,
at this moment.
Okay. Okay, that makes sense. But yeah, I really like the 4 different use cases. I guess you have a GitHub repo with all those examples.
Sure. Yeah.
Maybe you can put it in the private chat here in the restream, and I share it, and then we will have to give the channel back. But if you have a last question, now is the moment in the audience, so don't be shy and ask your question now. Of course, the replay will be available. The URL that you see in YouTube is also the URL of the replay. Okay, I put also so I will put now the GitHub repo. In the beginning, I also put Daniel's Twitter handle. So if you have any other question that pops up later, don't bother. Just send him a tweet, and he will be more than happy to reply to you. Let me see. No other questions. No. Okay. Hey, we are a bit over time, so I have to give the channel back. But
Sure.
again, it was really awesome. Really 4 different, really comprehensive use cases that really give the complete panel of how we can do modern autoscaling with events stuff, and with awesome projects like KEDA that I didn't knew really well, that I will play with, and Knative, which is one of my preferred technology out there in the Kubernetes ecosystem. Hey, Daniel, thank you so much. We will meet in a few weeks in Rio, in Poland, for DevX Poland. That will be awesome.
Absolutely.
I'm really looking forward to that. In the meantime, everyone, thank you everyone for attending. See you again in I think next week will be the show, not with me as host, but with Anna, I think, awesome guest. And the week after we will be back, or end of the month we will be back for another tech talk. So until then, please stay safe. Enjoy the rest of your day, and see you later. Bye, everyone. Bye.